Polynomials is Unit 3 of the course Applied Algebra or APA. There are 5 objectives in this lesson, and we are going to discuss each objective. Objective number 1, define polynomials and identify the degree of a polynomial. So this is the definition of a polynomial. A polynomial is a mathematical expression defined as a sub n, x to the power of n, and so on and so forth, plus a sub 0, where n is a non-negative integer. So these are examples of polynomials. 5x plus 1, 7x squared plus x plus 13, x cubed plus 2x squared minus 8x plus 2, 2x to the power of 4. Now, let's identify the degree of a given polynomial. Example number 1, x to the power of 4 plus 5x cubed minus 6x squared minus 4. So the degree of a polynomial is just the highest exponent. So in example number 1, it's 4. And in example number 2, if we are going to look at our polynomial, the highest exponent is 6. So the degree is 6. How about if we have many variables in each term of our polynomial? Like this, example number 3, xy cubed plus 5x to the power of 4 y cubed minus 6x cubed y squared minus 4x squared yz. So what we will just do here is add the exponents in each term. So for the first term here is 1 plus 3, that's 4. Second term, 4 plus 3 is 7. Third term, 3 plus 2 is 5. And then fourth term is 4. So the highest sum is 7. So the degree is 7. For example number 4, we will do the same. Add the exponents in each term. So first term, 1 plus 1 plus 3 is 5. Second term, 1 plus 1 plus 4 is 6. Third term, 1 plus 1 plus 6 is 8. Then fourth term, 1 plus 2 is 3. So the highest sum of the exponents is 8. 1 plus 1 plus 6. So our degree is 8. Objective number 2, add and subtract polynomials. So we have here example number 5, 3x cubed plus 2x squared minus 5 plus x cubed minus 6x squared plus 3. We can add or subtract the coefficients of like terms. When we say like terms, same variable and same exponent. So in this case, we have 3x cubed and x cubed as similar terms or like terms. So we can add 3 and 1, so that gives us 4. Then copy down x cubed. Then we have 2x squared plus a negative 6x squared, we have negative 4x squared. Then we have the constant here, negative 5 plus 3, that's negative 2. So this is our answer. Example number 6, 7x squared minus 5x squared is 2x squared. Then we have 6x minus negative 8x, that's 14x. Then negative 4 minus negative 11 is positive 7. So this is our answer. Objective number 3, multiply polynomials. Example number 7, we have here 3x squared times the quantity 4x squared minus 5x plus 3. So it's a monomial times a polynomial. So we are going to apply distributive property of multiplication. So we will multiply 3x squared times 4x squared, that's 12x to the power of 4. Then 3x squared times negative 5x, that's negative 15x cubed. Then 3x squared times 3, that's 9x squared. So this is our answer. Example number 8, we have the quantity 2x plus 5 times the quantity x minus 6. So here we are multiplying two binomials. So we are going to use the FOIL method. So we are going to multiply the first terms, f, 2x times x, that's 2x squared. Then O, the outer terms, 2x and negative 6, so that's negative 12x. then I, the inner terms, that's 5 times x, that's positive 5x. Then L, the last terms, 5 times negative 6, that's negative 30. So our final answer is 2x squared minus 7x minus 30. Example number 9. So we are multiplying two trinomials. So we are going to multiply 3x squared by x squared. That's 3x to the power of 4. Then 3x squared times negative 6x. That's negative 18x cubed. Then we have 3x squared times 4. That's positive 12x squared. Then 2x times x squared. That's 2x cubed. I write it here to align with negative 18x cubed because they are like terms. Then 2x times negative 6x, that's negative 12x squared. Then 2x times 4, that's positive 8x. Then negative 1 times x squared equals negative x squared. I write negative x squared here to align with positive 12x squared and negative 12x squared because they are like terms. Then negative 1 times negative 6x, that's positive 6x. Then negative 1 times 4 is negative 4. Now we are going to collect like terms. So 3x to the power of 4 by itself, negative 18x cubed, and 2x cubed, that's negative 16x cubed. Then we have positive 12x squared, negative 12x squared, and negative x squared is negative x squared. Then we have 8x and 6x, that's 14x. Then copy down negative 4. So this is our answer. Objective number 4. Multiply two binomials using special products. So we have our first pattern here. So that's the quantity of a plus b times the quantity a minus b equals a squared minus b squared. Meaning to say, if we are going to multiply the sum and difference of two terms, so we will just multiply the first terms. So a times a, that's a squared. Then minus, multiply the second terms, b and b. So that's b squared. Example number 10. So multiply the quantity x minus 4 times the quantity x plus 4. From our pattern, we multiply the first terms, that's x squared. Then it's always minus. 4 times 4 is 16. So that's minus 16. So this is our answer. Example number 11. The quantity 2x plus 5 times the quantity 2x minus 5. So we will just multiply the first terms, 2x and 2x. That's 4x squared. Then always minus. So 5 times 5 is 25. So this is our answer. For objective number 4, we have another pattern here. So that's the quantity a plus b times the quantity a plus b, or the quantity a plus b squared equals a squared plus 2ab plus b squared. How did we get this? We will just square the first term a, so that's going to be a squared. And then we multiply the first and the second term, a times b, that's ab, then double it, so it becomes twice ab. Then square the second term b, that's b squared. And also, the quantity a minus b times the quantity a minus b, or the quantity a minus b squared equals a squared minus 2ab plus b squared. How did we get that? So we square the first term, a times a is a squared. Then we multiply a times negative b, that's negative ab, then double it, we have negative 2ab. Then square the second term, negative b, so that's b squared. Example number 12, the quantity x plus 6 times the quantity x plus 6, or the quantity x plus 6 squared. So we are going to square the first term x, so it's going to be x squared. Then multiply the two terms, 6 times x, that's 6x, then double it, so that becomes positive 12x. Then square the second term, 6, so 6 times 6 is 36. So this is our answer. x squared plus 12x plus 36. Example number 13, the quantity 3x minus 7 times the quantity 3x minus 7, or the quantity 3x minus 7 squared. So first we are going to square the first term, 3x times 3x, that's 9x squared. Then multiply the two terms, 3x times negative 7, that's negative 21x. Then double it, it's negative 42x. Then square the second term, negative 7 times negative 7 is 49. So this is our answer, 9x squared minus 42x plus 49. Objective number 5. Factor polynomials using the following methods. We have many methods, so this is the first one, greatest common factor. So example number 14. So the greatest common factor between 4 and 12 is 4. Between x to the power of 3 and x to the power of 6, it's the one with the lower exponent, which is x to the power of 3. And between y to the power of 4 and y to the power of 2, it's the y to the power of 2. So this is the greatest common factor, 4x cubed y squared. Now 4x cubed y to the power of 4 divided by the greatest common factor, which is 4x cubed y squared, is y squared. And also 12x to the power of 6 y squared divided by 4x cubed y squared is just 3x cubed. So these are the factors, 4x cubed y squared times the quantity y squared plus 3x cubed. Example number 15. 15x to the power of 4y minus 25x squared y cubed. So the greatest common factor between 15 and 25 is 5. Between x to the power of 4 and x squared, so it's x squared, the one with the lower exponent. Between y and y cubed, it's y. So the greatest common factor here is 5x squared y. So 5x to the power of 4 y divided by 5x squared y equals 3x squared. And negative 25x squared y cubed divided by 5x squared y equals negative 5y squared. So these are the factors, 5x squared y times the quantity 3x squared minus 5y squared. The second method, the difference of two squares. So if we have a squared minus b squared, it's the quantity a plus b times the quantity a minus b. So meaning to say, we will just get the square root of the first term a squared, which is a, and also the square root of the second term b squared, which is b. And we will just make two binomials that will make the product of the sum and difference of two terms. So example number 16, x squared minus 100. So the square root of x squared is x, and the square root of 100 is 10. So we will just write the quantity x plus 10 times the quantity x minus 10. Example number 17, 4x squared minus 25. So the square root of 4x squared is 2x. The square root of 25 is 5. So we will just write the quantity 2x plus 5 times the quantity 2x minus 5. The third pattern here is perfect square trinomials. So we have a squared plus 2ab plus b squared can be factored as the quantity a plus b times the quantity a plus b, or the quantity a plus b squared. So following the pattern, we can factor example number 18. So this is a perfect square. So the square root of x squared is x, and the square root of 25 is 5. So we will just write the quantity x plus 5 times the quantity x plus 5, or the quantity x plus 5 squared. Example number 19, 9x squared minus 12x plus 4. The square root of 9x squared is 3x, the square root of 4 is 2, and the sign of the middle term is negative. So we can just write the quantity 3x minus 2 times the quantity 3x minus 2, or the quantity 3x minus 2 squared. This is our fourth method. That's the sum or difference of two cubes. So for the sum of two cubes, it's a cubed plus b cubed. The factors are one binomial and one trinomial. So for our binomial factor, we will just get the cube root of a cubed, which is a, then the cube root of b cubed, which is positive b, and then for our trinomial factor, we will just square the first term a, that's a squared. Then we are going to multiply the two terms a times b, which is ab, and we will just change the sign. We'll make it negative ab. Then we will square the second term b, that's b squared. So example number 20. So x cubed plus 27. So our factors are one binomial and one trinomial. So the cube root of x cubed is x. The cube root of 27 is 3. Now for our trinomial factor, we square the first term, x times x, that's x squared. For our second term, we multiply 3 times x, that's 3x, then change the sign, make it negative 3x. Then square the second term 3, that's 9. Example number 21, 8x cubed minus 125. This time it's minus. So we have again two factors, one binomial and one trinomial. So the cube root of 8x cubed is 2x. The cube root of negative 125 is negative 5. Now for our trinomial factor, we square the first term, 2x times 2x, that's 4x squared. For our second term, we multiply the two terms, 2x times negative 5, that's negative 10x. We will change the sign. It's positive 10x. Then we are going to square the second term, negative 5, so that's positive 25. This is the fifth method, factoring quadratic trinomials. Example number 22, factor x squared plus 7x plus 10. So the factors of this quadratic trinomial are two binomials. So the factors of x squared are x, and then the factors of 10, the last term, are 5 and 2. So these are the factors, the quantity x plus 5 times the quantity x plus 2. Example number 23, factor x squared minus 10x plus 16. So the factors of x squared are x and x. Then the factors of positive 16 that will give us the sum of negative 10 are negative 8 and negative 2. So these are the factors, the quantity x minus 8 times the quantity x minus 2. Example number 24. Factor 2x squared plus 11x plus 15. The factors of 2x squared are 2x and the factors of 15 are 5 and 3, that we cannot switch 3 and 5. So how do we know where to write the 5 and where to write the 3? We can check it by multiplying the inner terms, that's 5 times x, that's 5x, and also the outer terms, 2x and 3, that's 6x. So the sum should be the middle term here, 11x. So these are the factors, 2x plus 5 times the quantity x plus 3. Example number 25. Factor 3x squared plus 5x minus 12. So the factors of 3x squared are 3x and the factors of negative 12 are negative 4 and 3. How do we verify again? We are going to multiply the inner terms. So that's negative 4 times x, that's negative 4x. And then we have 3x times 3, that's 9x. So 9x and negative 4x gives us the middle term, 5x. So this is the sixth pattern. This is factoring by grouping. So example number 26. Factor 2x cubed plus 8x squared plus 3x plus 12. So we are going to make two groups here. So the first group contains 2x cubed plus 8x squared, and the second group contains 3x plus 12. First, we are going to factor the first group. So the greatest common factor between 2x cubed and 8x squared is 2x squared. Then 2x cubed divided by 2x squared is x, and 8x squared divided by 2x squared is 4. And we are also going to factor the second group. So the greatest common factor between 3x and 12 is 3. Then 3x divided by 3 is x, and 12 divided by 3 is 4. So notice here we have a common binomial factor, x plus 4. So this is our first binomial factor. The greatest common factor on our first group is 2x squared and 3 on our second group. So the second binomial factor is 2x squared plus 3. So these are the factors. Example number 27. Factor x cubed plus 5x squared minus 6x minus 30. Again, we are going to create two groups here. Notice here that the two groups are separated by a minus sign, so we have to change this negative sign here to positive. Because if we multiply back negative times 6x, that's negative 6x, and negative times positive 30 is negative 30. Now we are going to factor the first group. So the greatest common factor between x cubed and 5x squared is x squared. Then x cubed divided by x squared is x. 5x squared divided by x squared is 5. Now we are also going to factor the second group. The greatest common factor between 6x and 30 is 6. And then 6x divided by 6 is x. And then 30 divided by 6 is 5. Now we have a common binomial factor, so it's our first factor. Then the greatest common factor on our first group is x squared and negative 6 on our second group. So the second binomial factor is x squared minus 6. So these are the factors. The quantity x plus 5 times the quantity x squared minus 6. Thanks for watching, guys. This is Teacher Rejil. Keep safe.